Today I'm going to show you one of my favorite chemistry experiments, and it's one of the simplest you can do because you can do it in your kitchen. So welcome to my kitchen and welcome to the Bald Chemistry Teacher. Okay, for this lab, really all you need is an empty soda pop can, and you need a pie pan. I prefer a metal pie pan, but a glass one could work also, as long as you're careful. And then you need a pot holder or some tongs. I'm going to be using these salad tongs. As long as the tongs can open wide enough to hold the can, you should be all set. And of course, you're going to need your stove. So all you need to do for this lab is take your pop can and fill it with about 1.5 centimeters, maybe 2 centimeters of water. You want just enough water to cover, you know how the curved bottom, the bottom of the can is curved. So just put enough water in to cover the entire bottom. And then you're gonna put it on the stove and turn the stove on. And you wanna heat up the water until steam is coming out. And when a lot of steam is coming out, then you're ready. Now, while it's heating, fill this up about 1/2 or 3/4 full of water. And then when the water is boiling and steam is coming out, you take the tongs, turn it over upside down into the pan of water and see what happens. Okay? That's basically all you have to do for this entire lab. So I would encourage you to pause this video right now. Go ahead, get a pop can, put some water in it, heat it up, turn it over using your tongs because it's going to be hot. Turn it over into the pan of water and see what happens. Then come back, watch the rest of this video. I'll do the lab real quick and we'll talk about why it happens and what exactly is going on here. Now the trick is going to be to set the can on the stove carefully so it doesn't fall through the grate. If you have an electric stove, this might work even better. And then you just turn on the flame and let the can heat. While we're waiting for the can to boil, we also want to get water in the pie pan. I would say at least 1/2 full, maybe even 3/4. Alright, I've got my pie pan with water in it right next to the stove, ready for my Mountain Dew. It's boiling, but I'm waiting for more steam. Alright, now that the steam is coming out furiously, I'm going to keep the can heating, come in with my tongs, and turn over the can into the water in one quick motion. And look at that. Now that is chemistry. All right, now we need to talk about why did the pop can go from this to this? What's going on here? Well, first let's think about why the water needed to be placed in the bottom of the can in the first place. What was the reason for putting the water in the bottom and heating it up? Would this experiment work without putting water in the bottom of the can first? Well, you could try that on your own, but you may not be super happy with the results because a little bit of water is needed. Because when we heat it and boil the water, it fills the can with steam. And if the can is filled with steam, what is the can not filled with? It's not filled with air. So when the can is full of steam, basically the steam chases the air out, at least most of the air. And then the can is turned over into the water. Now, the water in the pie pan serves one purpose. It's simply to seal off this opening so that no air from the outside can get into the can. So once the can is upside down into our pan, what happens to the steam inside? The steam condenses back into liquid water. So now all of a sudden there's not much gas inside the can. The air was chased away by the steam, and the steam has become liquid. So now there's not very many gas molecules inside the can compared to outside the can. Now remember, gas molecules are constantly in motion. They're constantly crashing into you and me and the can. So right now, when the can is open to the air and it hasn't been heated, there's air inside the can and outside the can. And inside the can, there are air molecules bouncing around and crashing inside the can, crashing into the can walls. Outside the can, there are other air molecules crashing. And so basically, the molecules crashing outside equal the number of molecules crashing inside the can, and so the can just stays like this. But after heating up, after the steam chases most of the air out and we turn it over into our pan, now what happens is the number of air molecules outside crashing into the walls of the can is way greater than the number of molecules inside the can that's crashing inside. The outside crashes way greater than the inside crashes, and the can crushes from regular old air pressure. The pressure right now that's pushing on you, pushing on me, and pushing on this can crushes the can. So right now, if there were no air molecules inside the can pushing out, this can would turn into something like this. So hopefully now you've learned how to do a simple kitchen experiment, and you've learned why the gas pressure behaves the way it does when we heat it up. So that's it. Thanks for watching The Bald Chemistry Teacher, and if you haven't done so yet, please like this video and subscribe to the channel.